Welcome to the Damcasters. I'm your host, Matt Bone. Aviation is at a fascinating crossroads. Aircraft that have defined civil aviation will soon be phased out, as the production of the 747 ends this year, and the A380 production lines have been quiet for quite some time now. In their place, we're seeing new composite aircraft such as the 787 Dreamliner and the A350 move into this high-volume passenger space. Aviation is also very much in the sights of all those who want us to reduce our carbon footprint, because it is a very visible sign of carbon emissions. As we look to the future of flight, well, we need a guide. So, luckily, I know just the chap. Joe Welding is an aerospace engineer with over 20 years of experience working in some very interesting areas of aerospace development. Personally, I think he's a bit of a visionary, and currently he's working in the electric aircraft space. So when the chance to grab some of his time came up, I jumped at the opportunity to start looking into what aviation in the future could be like. Joe and I go deep in this one, so we're going to split it into 2 episodes because we have to look at lots of the facets that will determine what the future of aviation could be and what could power it. So this week, we're going to chat about the problems aviation is facing now and how future aircraft can be fueled and powered. Next week, we're going to look at how these new aircraft will look, but also how they can impact the airports that we use. So let's delve into this. As we're at a crossroads in aviation, I start by asking Joe, is it just the carbon issue that is making us look away from the traditional forms of aviation, or is there something else that is driving this change into new spheres of flight?
I think it's multiple things. The civil or the airline world, aviation world is ever changing in like what is the best way to operate, and you see that over time. You know, the airplane sizes have changed over time. On the very large end, like you were just saying, the 747 and the A380, tended to be built around a very definitive hub and spoke model where you were trying to pile as many people into as big of an airplane as possible between your very large city pairs, and then have a whole feeder network that were getting people to those hubs. And the primary reason for that was bottom line cost efficiency. So for the most part, the larger the airplane you build, the more economical it is to operate. Because a lot of things like pilots is a good example. You need 2 pilots for a large 78 or 747 or a large jumbo wide body, whatever you want to call it, and you need 2 pilots for a little regional jet. So the bigger you can go, you can cut down on pilot costs. And that kind of same idea scales to a lot of different things on airplanes. On the flip side, your hub and spoke model, a lot of travelers don't like it because they love direct flights, right? Like they love going city to city with your smaller city pairs. And so I think over time, even though the economics drove toward the bigger airplanes, the customer demand was more point to point. I don't want to spend a whole day flying because I'm sitting at another airport for 2 hours where I wait for my second flight to board. So I think that the industry is kind of just moving back in that direction of smaller for that reason. On the very small end, you get a lot more complication in there. There's like pilot clauses and pilot union rules and stuff like that that have really affected the very low end of the airplane market. And so what used to be a lot of very common 20, 30, 40-seater regional airplanes have almost all gone away. And it's for the dual reasons. There's economy of operating costs, but also some of those kind of less physically based things like pilot clauses that have kind of affected that world as well. And in the mid-size regionals has affected that a lot as well. So anyway, those stories, the cost competitiveness and all those other influences have always been around. They're always ever evolving. Nobody can ever really decide what the best answer is. In recent times, it's called the last 5 to 10 years in aviation, there's been a lot more of a push to make airplanes more efficient, and most importantly, to eliminate or to reduce greenhouse gas emissions and carbon and so forth. So right now, just in the last couple of years, you're really seeing a lot of activity in that direction on how to develop airplanes that are more sustainable from an energy and from a fuel standpoint. And that is not an easy problem to solve. I'm sure we'll get more into this, but it's challenging because aviation has such a unique kind of performance point that requires high performance on the entire airplane, not only the aerodynamics and the weight efficiency, but also the propulsion systems. and that also then necessitates a very energy dense fuel, which jet fuel is a good answer for that if you're just talking about efficiency of the airplane, forgetting the carbon emissions for a minute. And so there's really no good substitute for jet fuel, is the bottom line. And so everything that's being tried right now, none of it's perfect. If it was, it would already be there and you would already be flying on it when you go to the airport. But all these things we're going to talk about have pretty significant challenges in one way or the other. So a lot of companies, a lot of ideas, a lot of companies working on ideas on how to solve that. But it's very much at the early stage of kind of this next movement in aviation.
For many people, we're calling this episode "The Future of Aviation," and for many, there is no future. It's something that is the huge carbon sink. It can't continue. But the sort of spaces that you're working in as well is showing that there are routes that we can take that's going to be a very different mode of aviation than the one that we're used to. And
Yeah.
like I said, we're gonna dig into that. But let's get one out of the way straight off, which is the glamour one. Those of us of a certain age will have remembered seeing Concorde fly over and that allure of getting across to New York. Going in May, and it's going to take a lot longer than 3 hours. Um, but you've just got the note here that supersonics are hard, isn't it? And it comes down to this idea of you can't fly it over land because of the boom, and then you can't make it a quiet boom because then the aircraft wouldn't work as a commercial aircraft. So let's sort of close this one off reasonably quickly. It's the glamorous, it's the thing you want. It's fast, it looks science fictiony,
Mhm.
but it's incredibly hard to do, and also to do it with the the lack of substitute for good old Jet A1 is going to make it very hard to realize, isn't it?
Yeah, that's right. So let's start with take the sustainability aspect out of it. And supersonics is just incredibly hard. Obviously, Concorde was certified many years ago at this point, something like what 60 years ago or something. And remarkable that that airplane did what it did in that time frame. Wildly successful, I think, for what it was. Uh, it actually turned a profit for many years. So it was a feasible thing. However, ticket prices were through the roof, and that really came down to fuel costs and it was a relatively small fleet, so there was not a lot of economy of scale there. But it was very much an elite product for business travelers and celebrities and so forth. Obviously, there's a bunch of companies working on trying to bring that back. One of which I used to work for. So it's I don't know. It's I think there's a 50-50 chance, maybe better than 50-50 chance there will be supersonic air travel again in our lifetimes. Skeptical that it's going to turn completely mainstream, like some of the companies are working on, where anytime you want to fly across the ocean, you're getting on a supersonic airplane. But I think there's a very good chance that we will see supersonic passenger travel again at some point in somewhat limited scales. The primary reason it's hard, like you just alluded to, is the sonic boom, which is possible. Like I think the technology exists to quiet that, but it has big implications on the airplane efficiency and the speed and so forth. So if we can bring supersonics back in some way, I think working on the sonic boom problem over time probably will happen. But you got to get just something viable first. I don't think any company's going to get there as a very first shot. There's just too many unknowns with it. The boom somewhat does limit the field as well, because once you say you can't fly over land, you got to fly over ocean. Now all of a sudden you need an airplane with a very long range, and therefore it's got to be a big airplane. It's got to be a heavy airplane because they carry a lot of fuel. So it would be really convenient if you could make like a regional jet version of a supersonic airplane, where it's small, it's fast, and cheap to develop. Cheaper, I should say. No airplane is cheap to develop, and you could just like go get out in the market and just get something and then let it grow and let it build from there, much the way airliners did over the years, right? A cross the ocean airliner was not the first airliner ever built. It was an incremental approach. But with the sonic boom problem, you can't really do that. You've got to go all the way right from the beginning, which is very hard. And then the final one that's really hard for supersonics is noise regulation. So as I don't know if you ever heard Concorde take off, if you were around it, but it was loud. Partially which because it used an afterburner, but even without an afterburner, pure turbojets are very loud. And then unfortunately, a turbojet is still the best way to make a high-speed supersonic airplane as far as cruise efficiency goes. There's no way you could ever certify a turbojet aircraft again and meet noise requirements. You've got to have a turbofan and ideally a relatively high bypass ratio turbofan. So solving that problem of supersonic. So there's ways you can help that, but none of them are in line or in step with airplane economics. So anything you do on the airplane to try to make it quieter for a supersonic airplane makes the rest of the airplane worse, heavier, larger, more fuel burn, etc. So that's the reason why I think it's going to be very hard for a supersonic airplane in our near future. With our current engine and fuel technologies, to really replace all international air travel. I would love for that to happen, but I don't see that without a step change in propulsion or fuel. Then you bring the sustainability side on top of that, which is what we're going to be talking about throughout a lot of the rest of this, because I think that is the future. Man, supersonics are even another step away from that because they just burn so much fuel. Um, and
I,
you look at like the electric side of things, and I don't see any way you could build an electric supersonic with today's technologies that has any kind of range. Which, back to the sonic boom problem, you have to have range on a supersonic airplane.
I always feel sorry for people who didn't get to experience Concorde. I remember when I used to work for an airline at Gatwick, whenever it used to divert in due to problems at Heathrow, the queue of people that would rush down to the end of, oh, I want to say 27, I probably got that wrong, because the fence was right by the end of the runway. So you could sit there. So as it took off, and Gatwick's not got a long runway, so just the short hop, they would turn the burners on, and it was fantastic. It was like
Yeah,
being kicked in the head. It was brilliant. Um,
yeah. If you're
but
an airplane buff, the noise is not a problem. It's pretty
no,
awesome.
no, it was fantastic. But let's get into the nitty gritty here, because we're looking at how we can continue to have high volume air travel, but with a fraction of the carbon emissions that we're in now. And it's what is it, about 5% of the world's carbon emissions are from aviation, which is a fantastically high number. Um, what are the two sort of main challenges that aviation faces when it comes to reducing that number down to make it more palatable for the wider world?
Yeah, I mean, it's like what I started with. Airplanes are a high performance machine that needs efficiency of weight and of volume. And so, like I said, jet fuel and jet engines are solve both of those problems. A jet engine is very light for how much thrust and power it puts out, and jet fuel is very good from an energy density standpoint. There's really nothing that touches it, short of nuclear, which has its own issues, as you can imagine. But there's really nothing else that even comes close. And so, but on the flip side, it's hugely, it's a fossil fuel. It's hugely carbon emitting, and so that's the real challenge: is how do you come up with some sort of an alternate energy source that can package both from a volumetric and a energy density per weight standpoint that can compete with that and can provide some sort of a propulsion system that they can power an airplane at high subsonic speeds, getting up 400 or 500 knots, like we've all come accustomed to in air travel. So anything you want to go do to solve that, you've got to figure out a way to come up with some sort of a combination of energy and a propulsion system, a way to take that raw energy and turn it into thrust that kind of fits in a similar packaging and it's just compatible with the way we know airplanes today. The obvious one that a lot of people were working on, which gets a lot of buzz in recent years, is what's called SAF, or sustainable aviation fuels, which is essentially synthetic jet fuel. So it's a near drop in for jet fuel, but it's not derived from fossil fuels. Instead, it's a chemical generation process that's using like a biomass feedstock, or in some cases pulling carbon out of the air, which is really cool, as far as decarbonizing the atmosphere. The problem with SAF, and so SAF is around. You can go buy it today. There's been flights with it, on the airline side, on the military side. There's a lot of PR, a lot of buzz around it.
Virgin did a test flight on it recently, didn't they? Yeah.
Yeah, yeah,
Mm.
exactly. And like I said, from a technology standpoint, with today's airplanes, it's almost a near drop in. There are some subtle changes you've got to make to the engine and to the fuel system, mostly around what I understand is SAF is a little more corrosive than jet fuel. So you got to make sure your seals are right and some things like that. But there's not a major technology change in order to use it. The problem with it is essentially comes down to it's not made in any significant quantities right now. And so the first problem that causes, if you want to use it, like if you're a business jet owner or something, you say, I'm going to start flying completely on SAF. The price point, I think right now, is something like 4 to 1 to jet fuel, such a supply and demand thing. That in itself is probably solvable. The problem is because of that, very few people are using it. If everybody went out to buy SAF, there's not enough to go around. and nobody really knows yet how to make it in mass quantities. A 737 flight uses something like, I forget now, 20,000 kilograms of fuel per flight. That fuel's 20,000 kilograms. It's massive. Like, that fuel has to come from somewhere. And we just, as a world, we don't have the generation capability. We know how to make it, but we don't know how to scale that up to the amount of fuel that's burned by aviation. And a lot of people are working on that, but there's no immediate path to just instantly overnight solve that problem. So it's a great idea to talk about, but the reality is it's just not reality yet.
So I'm going to jump to my favorite hope for the future when it comes to fuel. Actually, before we do that, let's talk about that 5%. That is, on the scale of it, a lot. But is the general perception for how much of the world's global carbon emissions is that aviation puts out, is it higher than that? Do If you were to ask somebody on the street, would they immediately pick a higher number? Um,
I think they would. It seems like I saw a study on this a while ago, but I don't remember the results exactly. But yes, you can argue both sides of that. You can say, oh, 5%, that's a big number. Also, you could say, but that's nothing. If you totally eliminate it, it doesn't really change all that much, the world. I do believe the general public's perception is it's probably like 30 or 40 or 50%, maybe even, or something. And I think the reason for that is airplanes are very uh, kind of in your face almost, right? Especially if you're around airports. You see these big things, they make a lot of noise. And I think people associate noise and pollution together, and maybe for the right reasons, especially you have images of old airplanes that are generating a lot of smoke and so forth. So I think in the general public, the perception is it's way higher than that. The thing about it is, though, is there's a lot of effort in the world right now to reduce carbon emissions across the board, electric cars and power plants, et cetera. If we don't solve the aviation problem, that 5% only goes up, as a percentage goes. So as fossil fuels get out of cars over time and so forth, that number is just going to keep going up. So I could see a scenario if we don't do anything about it in, I don't know, 20, 30 years, it could be 50%, 30, 40, 50%, something like that. So
so there's an opportunity now to start leaning towards at least keeping it at 5 or maybe even reducing it. And that's what we're going to talk about as
yeah.
we go forward, some of those options. So let's dive into this. I'm gonna save hydrogen for later because that's the one I I think that's the future, ladies and gentlemen. Anyways, but electrics, and this one is very interesting. It's where you're working at the moment. We're not going to be discussing that. So if you're wanting any insider tips, people, you're gonna have to go elsewhere. But battery powered aircraft, I think, is such a fascinating area. What are let's do the pros and cons here.
Mhm.
What are the prawns? Very jet lagged, everybody. I apologize. What are the pros of an electric aircraft? Because I think there are quite a few, and you're
Mhm.
exploring them at the moment. So let's run through them. What's your sort of big ticket items that make an electric aircraft appealable?
Yeah, I mean, it's in some ways it's the most obvious answer, especially in our current mindset of electric cars are becoming very mainstream, and they're relatively simple, right? You have a battery, you have a motor, and some electronics in between, and there's no reason you can't apply that same basic technology to an airplane. And so an electric car obviously has an electric motor, which produces a torque and a power at the shaft. We've been powering airplanes with that sort of a device forever. It's called an internal combustion engine. So from there, you can turn it into a propeller, a ducted fan, like that. That technology on how to turn that power into thrust is very known, and it's relatively efficient. So that's all in the positive category. I think another positive of it is electric systems tend to be very reliable. The electric motors are almost foolproof. They're a lot better reliability than a internal combustion piston engine, and even a jet engine, which has much higher stressed components. A lot of them have, internal combustion engine has reciprocating parts that are essentially trying to fatigue themselves apart or vibrate themselves apart. So an electric motor, for the most part, doesn't have that problem if it's designed properly. Electric motors are highly efficient. Getting a 95% efficient electric motor is relatively easy, whereas a internal combustion engine is like 30 or 35% efficient. So you're using the energy that you have for exactly what you need it to have for. And then I guess maybe starting with the thing I should have started with, is that battery technology is completely clean, right? It's no emissions. There's no carbon, there's no water vapor that is put out of the airplane, no nitrous oxides, nothing like that. It's completely clean. The small caveat there is you have to recharge the battery. So where you get the power from to recharge the battery is always a question, which applies to electric cars and so forth. And that kind of gets back to the renewable energy source that a country or the world has. And as we get more and more, where's all that energy going to come from? Because you still got to have a source of that energy. But assuming you can solve that, once the airplane's flying, it's zero emission. And then there's some other things, in general, the batteries are terrible from a weight standpoint, but the motors are not. Motors are a very efficient way of producing that thrust as opposed to a internal combustion engine or even a jet engine. That gives you some flexibility, like where you place them on the airplane. You can also go to an idea called distributed propulsion, which means you have a lot of small motors instead of one or two or three large ones. There's some benefits potentially to that on a bunch of things on the airplane. Theoretically, efficiency, maybe some high lift if you can like blow air exactly where you want it over the wing or over flaps. There's possibly some aircraft control that can come out of that. Think like vector thrust, like on a fighter. You could theoretically do that better with distributed propulsion than you can with just one or two, big propellers or fans. So a lot to explore there. And I think if we get further into the airplane electric aircraft development, you'll see a lot of novel ideas start to come out and start to get applied to the airplanes that probably make them even better.
So that's why we're seeing at the moment a lot of concepts, a lot of early test aircraft that do have what look like lots of small propeller
Yeah.
engines all over it. It's a distributed model of being able to put power where you need it, as opposed to having something big and heavy hanging off of a single spot.
Yeah, and there's really two reasons for that. One is all the reasons I just gave. There is some potential advantage to it. The other reason that you're seeing that a lot is it's at the moment it's kind of necessity if you're going to build a very large airplane. So the state of the art right now on what I'll call small, efficiently packaged electric motors. So think of like what's in an electric car. That size of that motor, which it depends on the car, but somewhere in the hundreds of kilowatts kind of range, maybe 200 to 500 at the top end. That is about the state of the art right now for a highly efficient, well packaged electric motor. So if you look at like regional turboprop aircraft, they're running turboprops that are putting out thousands of shaft horsepower, sometimes many thousands. There really is no motor right now that can compete with that from a size standpoint. There are some people working on it, but right now it doesn't really exist. Whereas highly efficient, highly well packaged 3, 4, 500 kilowatt motors are very state of the art right now. So if you're trying to build a small airplane, a 2, 4, 6 seat airplane, you can get by with like two motors of that size, and it kind of looks like a conventional twin airplane. If you're starting to get bigger, so you're starting talking to a regional commuter type aircraft, so 15, 20, 30 seats, you need more than two of those motors. You might be able to get by with four of those, in a pretty traditional arrangement, four motors, two on each wing with propellers. In that lower side of that, 10 to 15 passenger airplane, maybe if you're starting to get up to 20 to 30, even four is probably not enough with that size motor. So then you're kind of, to use today's state of the art motors, you need to go to distributed propulsion. So that's the other reason you're starting to see that. I think that'll change over time, assuming this idea takes off. I think larger motor development will become a thing. But on the other hand, because of the maintenance and the reliability of electric motors is so good, there's really no downside to putting a bunch of small ones on your airplane. And there are some benefits as well. Whereas trying to build an airplane with, 10 or 20 reciprocating engines would be a nightmare. You would be losing an engine every day you took off.
And that's where we come down to this. It's making it an economically viable product. So with an electric engine, very few moving parts can put. Yeah, okay, you'd say a jet engine's got very few moving parts, which is true, but it's still, that's why the jet engine has proven itself all these years. It's a lot simpler than an internal combustion engine, and it produces what we need it to at a price point which is appealing
Yep.
to a degree. Now the cons. We're going to talk batteries here, because
Yep.
we all live with the nightmare of a percentage counting down on our phones every day. I would assume, and I'm going to be a bit flippant here, that you don't particularly want to be firing up an aircraft and having that big counter going down on the cockpit going, yeah, you're down to 12%. Do you want to enter battery saving mode? As everybody's phone does by about 4 o'clock in the afternoon. What's our issue with batteries besides, I suppose, them being big and heavy?
Well, it really is they're big and heavy is the real problem. We can deal with the big, but the heavy is the problem. So pure energy density, which is how much power or how much energy they contain for how much they weigh. The current state of the art in batteries is about 40 times worse than fossil fuels. 40 times, which is really, really a big difference. Now, there's one caveat in here, and this is a good, helpful caveat if you're a fan of electrics and batteries. We mentioned earlier, an electric motor, an electric propulsion system is about 90 to 95% efficient. Anything that's using fossil fuels, the best that gets is probably 40% efficient, and reality is probably more 30 or 35% efficient. So even though the power source itself is very good for fossil fuels, the engine is not capable of really fully harnessing that power. So you have to really multiply those two numbers together, and when you do that, the battery propulsion, electric propulsion system as a whole is really probably only like 10 times worse than fossil fuels. Only 10 times, right? So it still is bad from an airplane design standpoint, but it's right at the point where you actually can make a practical airplane with that, with a whole lot of caveats. But yeah, that's so as far as cons go of batteries, that is really the big one. If that number was better, and it's getting better all the time, but unfortunately at a very slow rate, you probably would see electric airplanes already have been developed. But that's really the real barrier. And it's hard for an electric car. It's even harder for an airplane where you've got to carry that weight. So that's the first one. I mean, there's some other side things on batteries that are cons. First of all, they have a life. I don't know the exact numbers, but charge discharge cycles on a battery is not indefinite. The numbers I've seen is on a typical like airliner type airplane that you're going to be flying multiple times a day, you're probably replacing those batteries something like once a year. So not terrible. It's not like you're replacing them weekly, but it's also not great. And so you've got to factor that into the cost of ownership of that airplane. Fortunately, what help offset that is because electric airplanes need to be efficient, your actual cost to operate the airplane is quite a bit lower. So the cost of energy is quite a bit lower than if you're buying jet fuel. So that kind of somewhat offsets that. But you do have to account for that, as well as the labor and the how do you get those batteries in and out of the airplane? How do you recycle them? And so forth. But so that's a pretty big con, yeah, or disadvantage.
And I suppose that's the knock-on effect. You while operating, you're running much more efficiently and cleaner, but then you have this byproduct of a whapping great battery that somehow needs to be recycled in a clean and manageable way. Again, we're hitting that sort of tricky trade-off part.
Right. Yep. And then on any of these new ideas, whether it's batteries or hydrogen or anything, there's also an infrastructure question, right? Like right now, airports are set up with fuel trucks and fuel tanks and storage and all of that, distribution and the whole supply chain side of it. And anything you change there, whether it's battery powered aircraft or hydrogen or whatever, like there has to be infrastructure change to go along with that. So charging stations at airports and getting more power to the airports, and how do you what's the power throughput versus you're storing it in some sort of a storage, another battery or whatever, and then how quickly can you charge and so forth. So all of those are solvable, obviously, but it's another barrier to entry for an electric airplane that has to be in place before you can just go show up at an airport and say, hey, I'm here, where do I charge? Much the same problem with electric cars. That infrastructure is still being built in most countries around the world. So
Yeah, because exactly, I used to work for Heathrow. There's literally a pipeline for jet fuel from the refinery to Heathrow, and
yeah.
that's what keeps it going. There would need to be that thinking to go in to electrics. And again, we're talking about designs of airports that are, in most cases, 60, 70 years old, where
Hmm.
this was never considered. So you'd be looking at a massive infrastructure change.
Yeah.
I'm not putting this off anymore. I want to talk about hydrogen because
Yeah.
I'm excited by it. You say hydrogen to people, they think Hindenburg,
Yep.
which okay, that's that. Fair enough. But hydrogen in and of itself is a very, when we're talking about the power that can be got out of it, it's quite impressive. So, what are the pros? Funnily enough, on our notes here that you sent me through, the cons are considerably longer than the pros, but we're going to get to that. Um, let's geek out on hydrogen for a minute, make me happy, and
Yep,
then you
yep.
can burst me like a dirigible.
Yeah, and yeah, exactly. So the big pro, hydrogen is very lightweight. It's got as short of nuclear. It's got one of the best energy. It might be the best. I don't know that anything beats it other than nuclear. Um, Energy densities of any fuel out there. So it's literally one third the energy density of jet fuel, which means for every kilogram of liquid hydrogen you have on your airplane, you're getting 3 times the energy out of it. So that's huge, right? So then another one is when you burn it, and essentially any use of hydrogen is some ways burning it, whether it's literally burning it, like in a you can run a jet engine or even an internal combustion engine off hydrogen. It's literally burning it. If you're putting it through a fuel cell, which is the other common way of using it, it essentially is burning it. It's not exactly an open flame, but it's a similar process. It's combining with oxygen. It's a oxidizing event like combustion is. So when you burn it, I use that term loosely, you have hydrogen, you have oxygen. There's no carbon involved, and so what comes out of that, your byproduct is water, which is great. So then if you're up in the atmosphere, you're not putting out any carbon. Actually, let's keep going through the pros. There are some little caveats on that, but there is no carbon that's being emitted from it, so that's great. And because of this, and it exists today, and it's like all the problems surrounding it, and we'll get to that in a second because there's a bunch of them. Theoretically, they're all solvable. Some of them are
You're
pretty.
spoiling my dreams here, man. Come on.
Yeah, but as far as like the best way to make a carbon neutral airplane today that has somewhat long range, I think it is hydrogen. Like really nothing needs to be invented to get a reasonably long range hydrogen or carbon free airplane. So that's a massive pro, right? Anything else you were talking about here, whether it's fuel cells or batteries or whatever, there's always a little caveat of like, oh yeah, in just a couple more years, this is going to be really great. but right now we're almost there, but we're not quite. And I would say hydrogen, we actually are there if you're willing to accept all the compromises that you have to accept. So um, yeah, it's going to be fascinating to see what happens with hydrogen in the next few years, whether people do kind of overcome those compromises or whether it gets kind of shoveled off to the side, which has been for years. Like people have been trying to build hydrogen powered vehicles for quite a while, and they always run into the problems with them and then push it aside. But it's a new environment now, so there might be more ability to get through that.
And there's a lot of investment going into it.
There, yeah,
Was
absolutely is.
Goldman's were just putting a bunch of money into it as well.
Yep,
So there's it's definitely there. In my head, all of these things, the electric thing, you come down to the fact that most of our electricities come from burning gas.
yep,
Let's hydrogen, which someone's going to crack it, but we'll think it takes. Yeah, let me throw this one in. Yes, the volume of it is massive because there isn't an easy way to squish it down into. And so even though you're getting 3 times the power for the same weight, the volume of it is considerably more than a kilo of good old Jet A1.
yeah. That's probably problem number one. So it's what you call volumetric efficiency is terrible. I think it's I don't know, 3 times or something worse than jet fuel. So if you think of how much tankage space there is on a modern airliner, you multiply that by like 3 or 4 in order to carry enough hydrogen to get to the same energy level. It's light, but it just takes up space. And unfortunately, in a modern airliner, space at a premium. If you go look at cross sections of a modern airliner, there is almost no empty space in an airliner. The wings are full of fuel, cabins full of either people or baggage or systems. About the only empty space you have is a little bit of space in the tail, in the very tail cone of most modern airliners. Everywhere else is full of something, which is why it's great for like a blimp or something, right? Because you've got this big, massive volume. So if you think about a hydrogen, like just taking an existing airliner, like a 737 or a 787 or whatever, and say, okay, we're just going to power this on hydrogen. You have to make space for the fuel. And the rough numbers I've looked at this one point is if you just took one of those airplanes called a 737, you would pretty much need to fill the entire fuselage with hydrogen tanks to get to the same energy level that you have in the wings of jet fuel with that type of an airplane. So obviously, directly as is, that's not practical, right? Because then where do the people go? Where does the baggage go? So of course, there was a hybrid approach there. We say, okay, well, maybe we fill half the fuselage with hydrogen and half with people. Could be a viable airplane, right? And now it's going to have half the people, so your operating cost per person is going to double, and so forth. So it's not a great answer either. If you go start to say, well, we'll put we'll stick something else on the airplane to hold the fuel, a nacelle or something like that on the wing or whatever. You could certainly do that.
Hydrogen drop tanks, that's what you
Yeah,
want.
drop tanks, right? But obviously that has pretty massive drag in weight impacts as well. So the practical side of it, if you're just trying to swap out an existing airplane, it doesn't really work. But I think that could probably be overcome, with creative design if you're going to build a new airplane. And certainly as either a demonstrator or a near term, like I said, like go halfway, fill half the airplane with fuel and half people, your operating cost goes up. But if it's carbon free, maybe people are willing to pay for that. So yeah, so that's his primary problem. There's a lot of secondary problems. Holding on to hydrogen, containing hydrogen is really hard, and from a couple reasons. One is liquid hydrogen is a cryogenic, which means it needs to be in a tank that is either high pressure or very cold or both. Some combination. There's trade-offs there, but so it's why most hydrogen tanks are spherical, which comes back to the packaging problem. Jet fuel is literally just a liquid. Dump it in any shaped container you want. Hydrogen wants, for weight reasons, a sphere or at least a cylinder, which is harder to pack inside of something like a thin airplane wing. And then that adds weight as well. So those tanks themselves offset some of the weight advantage because a airliner's fuel tank essentially doesn't weigh anything. It's called the wing. It's already there. You're sealing it, you're dumping fuel in. So that doesn't work with hydrogen. You've got to create these tanks that can hold high pressure and be insulated and so forth. The other problem with hydrogen is it's such a tiny molecule, it wants to leak out of everything. Like my analogy I like to tell people is hydrogen is kind of like a cat. Imagine trying to make a cat tank. Those cats are going to get out. And hydrogen is the same way. It's very hard to seal it. So hydrogen leaks are a big problem. Again, it's solvable, but it's much harder to deal with than jet fuel. And of course, it's highly flammable, so there's crashworthiness issues. Again, I think it's solvable, but it's in a crash, it's going to be worse than jet fuel potentially. And there's a perception problem with it as well, and I think it's mostly due to Hindenburg. But I think, again, solvable. But I think a lot of people, when they think about a purely hydrogen-powered airplane, are going to be very leery of that. So totally solvable, especially if it's actually carbon-free and you can get it certified. But initially, I think there's only going to be a lot of pushback on that topic.
And that's one of the benefits of kerosene, isn't it? It's flammable, but it's not that flammable, if that makes sense. So it's not, if we go the other way, we've got petrol or gas, which is highly volatile. It's this pretty amazing middle ground for operating in a jet engine. But
right. And then the final one on hydrogen is, even though it doesn't emit carbon, when you're flying into the atmosphere, it's still not perfect because you are putting out a lot of water vapor, which makes contrails. And a lot of the environmentalists will say that contrails are an equally bad problem, not just carbon emission in the upper atmosphere. And depending on how you're burning it, certainly if you burn it in a jet engine where you've got a high temperature combustion in the presence of air, it makes nitrous oxides. So NOx is still a byproduct, even though the fuel itself doesn't have that. It's the environment that you're burning it in still creates nitrous oxides, which is also bad for the atmosphere and for the environment. Not nearly as bad as carbon, but it is another problem. I actually don't know much on this topic. I don't think fuel cells have that same problem. I think they still emit water vapor at altitude, but not the nitrous oxides. So again, it's one of those things where it's better, but it's still not perfect. Whereas as opposed to batteries, do not produce anything at altitude. So all of this is a trade-off.
And that contrail thing is always interesting, is because it's putting water vapor where water vapor shouldn't really be. So that's the thing that's contributing, and it's not stuff that's making us all impotent and infertile like some crazy people like to think. So okay, so you've shot me down on hydrogen. That's not gonna happen. I think that
not I've tempered you. I haven't shot you.
It's yeah.
I give you a warning shot.
Like
all of these, there's no perfect answer here.
So somebody's going to figure it out, and they're either going to disappear or become incredibly rich. We've talked about the sustainable fuel, the sustainable aviation fuel again. It's one of those things that on paper you think is a good idea, but then it's the manufacturing of it as well, which again isn't as green as you would think. Like a lot of biofuels as well, a lot of energy goes in, a lot of land for the base ingredients for it. So we won't spend too much time on that. But the one that sort of caught my eye,
Mhm.
you threw solar onto your list. And having just spent 17 hours on a flight back from Perth, of which most of it was at night, that one worries me a bit. But how would solar work into an aircraft besides that? Because solar, daylight, that immediately limits when you can fly. But I'm intrigued by this. Sell me on
Yeah.
it.
Yeah, it's it's just like all of these. Sounds great when you first hear it, but there's so many limitations to it with the current technology. And I guess there's two big ones on solar. One is you don't always have it. So it's and that's true of solar farms or whatever, right? So it's a good what I'll call a supplemental energy source, but you really can't rely on it as your primary energy source, right? Like building an airliner that could only fly on sunny days would not be a viable business
Mhm.
model. So that's the first problem with it. Probably the bigger problem is just it's kind of the scalability thing is photovoltaic cells, so cells that'll take solar power and turn straight into electric current, um, are very large for how much power they actually produce. I don't have any numbers on this, but the one data point I know on this is there's been several solar powered aircraft that have been built to date. Most of them look like sailplanes of some sort, sailplanes or like, but they've got massive wing area. They fly at very high altitude, very slow, very a high efficiency range of flight. And the key there is wing area. So most sailplanes, fly at low speed, so they have very large wings. Same with these high altitude UAVs that NASA and other companies have built. Um, so you have a lot of surface area to be able to put these. I've never done this, but it'd be interesting to run the numbers like on something like an airliner of like how much more wing area would you need to make that viable. And my guess is it's probably like a factor of 10 or something, at least five. Like it's just it sounds like a good idea, but it just doesn't scale. Now, if somebody could design a solar cell that could, have half the area or a tenth of the area for the same power output, then that could very much be a game changer. But that's just not reality right now. And I'm sure people are working on that, but it's not something I've heard of. There's a lot of development in that area. They're also heavy. They tend to be made of either glass or some sort of a transparent plastic or something that have a certain amount of thickness in there, so they're not super lightweight. Um, so yeah, it sounds good in theory, and some of those airplanes that I just talked about have had some pretty remarkable records. I think the record right now for a solar powered airplane has been in the air for like 4 days without refueling or something like that, maybe 5 days. I don't remember, but it's pretty remarkable. But again, that's not a practical airplane, right? It's looks nothing like an airliner. Um, and then all your secondary ways of generating power through solar, which is the way a lot of like solar fields work. It's not actually directly creating electricity. It's heating up water and then generating it into steam and running it through a turbine and whatever. None of that works on an airplane. You just can't afford the space or the power or the weight necessary to create some sort of a solar system like that.
So immediately we're into that tricky area of commercially viable, but then operationally viable as well. So there you have it. Solar powered mass market flight is out for now. But next week, we're going to check in to see if nuclear power could be the future, just as old Curtis LeMay had dreamed of back in the 50s, of aircraft that never had to land. Is that really going to be a thing? Find out next week. We're also going to look at how the impact of these new forms of power will change the airports that we use, because they're not designed to plug an airplane in to a socket. If you want to follow Joe on social media, I've popped a link to his Twitter in the description for this episode below. As you can imagine, the things he's working on are not highly publicized, so there are no links to the project that he's working on just yet, but if you give him a follow, maybe there'll be some announcements soon. As always, I have to thank you for the incredible support of everyone who's been listening and sharing the podcast over the last few months. It's been humbling to see the download numbers go up and up, and thank you. Really do mean it. Of course, if you can leave me a review on the podcast app of your choice, that'd be great. Stick some stars in. That lets me know how we're doing, helps with the algorithms and the charts, Of course, telling your friends is the easiest way to share the show with everybody, and I'd be super grateful for that. If you want to get involved a bit, there's the Patreon page. Again, the link for that's below. That starts from about £3 a month, plus a bit of VAT. You get a thank you card from me. And there's some merchant bits as well at certain tiers. But we get to chat about planes, and I pop random things up on the Patreon feed as well. So, until next week when Joe returns and we delve into the final part of our conversation, thank you. And as always, do take care of yourselves. The Damcasters is hosted and produced by Matt Bone, and it is a Boney Abroad's podcast production. To check out our other podcasts, head to boneyabroad.com.